Così non si vede niente, così è troppo. No way.
Ciao a tutti. Good evening, everyone, and welcome to this new session of the Meetup group in Turin. We're going to talk about value stream management today. So we're doing this in English as usual for the people that can watch this on the live stream session. If you are here or for the people that are connected remotely, you can post messages and questions also on the different social channel, and we will try to answer to your question, or you can rewatch again later if you cannot attend the entire session for today. So thanks a lot for spending your Friday evening with us, and let's start with the subject of today. We're going to talk about value stream management. So today we're not talking about a technology, we're not talking about product, we're talking about methodology to manage your activity, your workflow, something that you can apply to your project or to your product that can help, can facilitate the delivery of a functional product for your end user. What we're gonna talk today is a brief overview, what value stream management is, where it comes from, what is the relationship between VSM and Lean or DevOps and Agile. We will try to explain which are the core principles of that and why this is a powerful tool, how this can extend the capabilities you have inserted in your project, maybe starting working following agile methodologies as Scrum or Kanban, or using DevOps technique. And we will try to see how this can be implemented in your flow of activities inside a software development factory. First of all, we're talking about value stream management. So let's try to define what is a value stream. So we are managing a value stream. What is a value stream? Value stream is the sequence of the activities, as you can see in the slide, to deliver a product or a service to your end user, to the customer, being internal customer or an external customer. It does not mean just to build the software that you are delivering to the customer, but is the entire flow. So from the demand, from the moment your customer is expressing a willing or a need, to how you collect that, you transform it into requirement, you create an analysis, and then you develop, and then you ship it to production. But also how you maintain that, how you provide support. So is the entire flow from the request to the actual usage of your solution or services by the end user. And value stream management is an approach of how to analyze and optimize which are the steps that you take to provide this value to the end customer. And the aim to identify and then eliminate the waste. So try to make the flow, the value stream that we mentioned before, more efficient. Core principle for value stream management are customer focus. So we're not talking about the detail of the technical implementation of a task, but delivering the value to the end user, to the value. And this probably is something that in your mind make you think about the principle of Agile or the principle of DevOps, where also there's this focus of the value for the end user. Another important topic for VSM is the value stream mapping. So the fact that you actually visualize your value stream and you define which are the elements that compose it. It aims for continuous improvement. So you try to correct continuously your flow to eliminate the waste. So you need to remove what is a non-value adding activity. Every time we do something, we have something that is value adding. For example, the code that we insert into our application to provide a functionality, but then we have also non-value added activity. Some of these are mandatory, are needed. Other can be more impacting in terms of waste. It can be a non-value added activity, something as a meeting, because it's not the meeting that is providing the value to the end user, but also adding useless code, working to create a functionality in your application that the user didn't ask for. This is also something that is non-value adding activity. And then it focuses on the flow itself. So on the different steps and how they are connected to each other. If we compare value stream management with a traditional project management approach, there are a series of differences that are important to highlight. The project management has a focus on the deliverable, on the milestone, on the control in terms of cost and time. You have a set of tasks that has a size that need to be completed in a certain amount of time, that need to have a certain dependence in terms of cost, and then you have a sequence, and then you have also a delivery date. And this is particularly true when you talk about traditional project management in terms of waterfall project management, but it's true also when you focus on agile project management, where you have a sprint and you focus on the fact that you have your user story that has a certain effort required and they need to be completed by the end of the sprint. This is not what VSM has a focus on. VSM has the focus on the flow and not on the timeline of delivering things. Is more an end-to-end process. It's not just the development part of that. While in project management, you have metrics related to cost, the schedule, the scope. When you work on the VSM, on a VSM model, you have as a measurement the cycle time or the lead time. So the time of the entire flow or a specific phase, not of the individual task. The time of the individual task is not something that you will measure using a VSM approach. Where it comes from, a bit of a history. Value stream management, something that you can read something about it at the beginning of the past century in manufacturing. It becomes much more popular and becomes something more structured with the Toyota production system mid of past century. And then it gained its own momentum in the 80s or the 90s of the past centuries with the publication of books like Lean Thinking that had the focus about this flow value, empowering the team, make continuous improvement. And in the last recent years, it expanded beyond manufacturing to enter into other industry, including the software development industry, digital industries, also with the emerging of DevOps practices that have created also more interest into VSM. If we look at this history, we look at that and we see, okay, but you're talking about Lean. Beginning of the past century, Toyota system, this is Lean. Value stream management and Lean, they have a very strict relationship, in fact. Lean's originating in manufacturing, Toyota production system, there's a focus on creating value, eliminating waste, having a process that is predictable, having the concept of continuous improvement. VSM is a part of Lean. It's born inside the context of Lean project management. But it's specifically defined as a set of tools and techniques to manage and optimize the value streams, the definition of what is the value that we are providing, which are the different elements that we compose the provisioning of this stream. And it adapts to the digital world today. They have a lot of shared goals because VSM rooted inside Lean. Identify and eliminate the waste, focus on creating value, optimizing the flow, the continuous improvements. VSM and Lean are not the same as we wrote in this slide, but they are closely related. Lean is a broader philosophy, is something, a set of principles and a set of various techniques, including Kaizen, Kanban, 5S. VSM is one of the specific tools that are part of the Lean toolkit. So definitely there is a strict relationship between the two things, but VSM, value stream management, is one of the tools of Lean, so it's not the entire toolkit of the Lean philosophy or methodology. There's also a relationship between Lean and DevOps. I mean, we are meetups that has a focus on DevOps methodologies and practices. So why we're talking about value stream management here? Because there's a relationship with DevOps. DevOps has a focus on breaking the silos between the development and operation, having a more continuous flow of activity between writing software and operating it and delivering it, and has the concept of continuous improvement and measurement of every data to try to optimize the result. All these things are part of value stream management, but value stream management, if we compare it to DevOps, has a wider focus. It's not just the relationship between producing and delivering a software, but it includes also the requirement gathering, the customer support, the customer care, the phases related to market analysis, and so on. Again, I can say VSM and DevOps are not the same, but they are often used together. The DevOps approach, promoting the automation, the continuous integration, the continuous delivery, the shared responsibility culture, it's a tool that can allow to optimize the value stream. And so a value stream management approach, when it does the analysis of your value stream to try to optimize and to make it a more efficient flow, very often in the when it comes to software factories or software company or digital company, the VSM does as an outcome try to ask to implement DevOps methodology to optimize the stream. We tried, I mean, you can recognize the style. I asked one of the most famous AI to draw this picture. I didn't do myself, it would be much more ugly. To try to picture what is the relationship between Agile, DevOps, and value stream management. They have a lot of common principle. Shared responsibility, focus on the value more than on the process, trying to eliminate the waste, trying to optimize the result and velocity to release value to the end user. But one way to see that is that Agile as a primary focus on the development team is something that was born to try to optimize the work of development team that with the standard processes was having too much waste in terms of processes, was too slow, was delivering things too late compared to when things were needed to the end user. But the focus of the Agile principle at the beginning had a focus that was very specific to the development team. As we already discussed in other meetup, DevOps is a bit of an extension of Agile because it takes lots of Agile principle and apply that to something that is out of the development team. But it's still in the IT department, it's still on the technology, it's more the IT operation part. It takes the Agile principle and say, okay, but this is not something that should live just inside the day by day of the development team. It should be, the same principle should be applied to the extended chain of developing, but also operating the software. But still, DevOps has a focus on the software production and operation part only. Similar principle in terms of optimization of the flow, customer focus, importance of the recognition of the value to be delivered is on value stream management, but with a view that it's much more holistic than the one of DevOps. So this is why we picture it this way. So Agile is included into DevOps. You cannot talk about DevOps without considering Agile. But DevOps itself, and so Agile that is inside DevOps, is included inside value stream management, because you cannot, in the digital area, in a software factory, in a software development company, no matter if it's a product or a project or service type of company, optimize your value stream without applying DevOps principle, and you cannot apply and have really the advantage of the DevOps principle without applying the Agile principle in the development part. Let's try to see what is value stream management a bit more in detail. So how we do use value stream management to try to optimize our flow. Working to try to apply this practice requires a series of steps that create a loop, iterative, where you go back from one to the other continuously. The first step is that you need to map the current state. First step, you define, you select a value stream, a set of process, something, a project or a service that you are delivering, and you try to map how this is done today, and try to identify which are all the different area of that. Then you analyze that in order to get measurement. Value stream management, we will see also in the next slide, is not much about feeling and perception, but it tries to measure things and to work on data, take decisions that are data-driven. You then define, you map your current states, you analyze it, you identify which are the waste or the inefficiency in your state, and you define your future state. Then you try to implement that, making the changes that you have defined. You measure again, because as I said, it's something that is really data-driven. So you take the same measurement that you had in the current state with your new state that you have applied, and you start again. You analyze, define again a new future state, and you try to implement, and then you iterate again. So there's a lot of focus on the fact that you design your map. So you design your workflow, the different stages that your process goes through. And here comes one of the most common mistakes when you talk about value streaming mapping. That is the fact that very often is confused with flow charting. So you create a flow chart of your flow. So you get a requirement, then you go to analysis, then you do the design, then you start development, you do the functional testing, acceptance testing, and you do the release. But the flow chart is something that is definitely useful, but it's not part of value stream mapping. Has a focus on illustrating what is the dependency between steps. So you do a flow chart because you need to define in your workflow what is the sequence. This is definitely something that is useful for value stream mapping, but is not the entire value stream mapping. Value stream mapping has not a focus on just defining which is the sequence of the activity, and so of the different phases, and so the different teams that are involved, but is there to measure what are the lead time and cycle time, process time, queue time, so the different phases that goes through the process. When you do a value stream mapping, you are not just designing the fact, and we will see a couple of examples after, you will not just define that you first have the requirement phase, and after the requirement phase, you go to the analysis phase, and then you go to the development phase. But you measure and put down, so you need to collect a lot of data, that the requirement phase take an average of 2 hours for each requirement to be written, but each requirement is on the queue before. From the moment it is inserted to the moment it is written, it starts to be written, it is queued for 1 day as an average. Then it takes 2 hours to be written. And then after it's written, it will take 1 day before it starts to be taken by the other team that will do the analysis, and so on. You need to identify all this measurement, and we see some other example after. And with this measurement, and you define a flow that is not just the dependency between the different stages, but is the actual timeline of the different stages, with also information about the error rate. how often these passages between stages is interrupted or is blocked, or how often this is circled back because, for example, I release a software, but then there's a bug, and so it comes back to development. It does not go to release state. And once you have map of this, you can identify which are the kind of information flow or material flow. These are two different kind of flow that are found in value stream mapping. Information flow is a flow, as the name say, of information, requirements, needs, problems, while the material flow is something more related to the actual artifacts that you are producing. And you can define where you can change this flow to try to optimize it. To do that, you do through a set of metrics. So a lot of focus on the value stream mapping is on identifying the metrics, identify how you can measure that and you can track them. Some of the more relevant metrics are the ones that are under the title of flow metrics, so metrics related to this flow of activity. Lead time, so the total time it takes to deliver the product or the service from the moment the need is arise and is communicated to the moment it is delivered. So again, it's an holistic view, so it's not just the time you make to develop something, but it includes how you track the fact that there is a request from the customer, how you collect, how long it takes to collect this request and transmit it to your software factory part. The cycle time, so the time it takes to complete a specific task or a phase or a stage that can be a group of coherent tasks. The throughput, so how the rate at which the work is completed, so how much you can proceed also in parallel on proceeding on the activity. The work in progress limit, it's anyone who work on Kanban is very clear what does it mean. So how much work we can have queued at the same time, and the frequency of your release of your product, in our case, a software. But you have to put together also other metrics as the quality metrics, defect rate. So how often it happens that what you are delivering is not in a good shape, and so you have to rework, because any rework is a non-value added activity. You had something to do, you did it, you deliver, is not what was expected, is not working as expected, you have to work it again. You have to do it, it's needed, because otherwise your end user does not receive the value it's expected to receive, but is wasted time, is not value added, because this is something that should have been there before, was not what was planned. In the meantime, to repair, this is particularly relevant when you are providing services in a production system, because the fact an issue can be something that comes from your factory, but there are also incidents that happen in an environment. And if you are delivering a service to your end user, you will be affected by incidents that are not due by something that you have done. It can be due to third party, to external elements, but this is breaking the chain of value and you need to repair. And so you need to understand how you are able to repair, to fix the problem or the incident that is there. Because again, fixing an incident is something that if we think about the SRE methodology, for example, coming from Google, is a toil. In this case, it's a waste. It's a non-value added. It's something that, again, is mandatory, is needed, because otherwise your user does not get the value, but is not something that produces the value. It's just something that restores a value that was already there. And so you need to understand how long you spent to do that. And then there are other metrics that are a bit more difficult to collect depending on where the kind of work or kind of service that you're providing. Customer satisfaction metrics. There are some standards there. The Net Promoter Score, the customer satisfaction score are some standardized way of collecting feedback from the customer and try to understand the level of satisfaction. You have metrics then that you collect after you started to implement your value stream management. the efficiency metrics. So you can try to measure, and you should, if you try to implement value stream management, the percentage of waste reduction. Every time you do a change in your flow, you need to measure the impact of this change. The value add percentage, so in your time, the total time, the lead time of providing your service, how much time is value added and time, and how much is non-value added time, and try to work on the percentage and see the changes, if they are improving or not this. And then you can have other metrics as the cost of poor quality, so how much impact you have when the quality is not at a high level, or the return of investment directly of your initiative, to try to measure how this is improving your flow. These are a bit more specific, doesn't apply on every kind of circumstances. It can be more difficult to measure. What does it mean to implement value stream management in your organization? So how can you start on that? We said more than once already during this presentation that value stream management is an holistic approach, view from end to end about all your flow, but is something that applies to each value stream. In your company, you can divide your activity into multiple value streams with internal or external customer. As usual, with every time you start with a new approach or a new methodology, you should start with something that is incremental and starting with something small. So you need to identify an initial product or initial service that you can define clearly the boundaries, and you start to apply this methodology only in that field. You cannot think about, okay, I want now to do the value stream mapping of my entire company, no matter if your company is good or good, big or small company. It would be incredibly difficult to apply it immediately from zero to everything. You need to split it into different stream and then define one stream, one product or service you want to apply that. And you need to involve the people. Involve the people, what does it mean? This is something that you heard about also when we talk about DevOps. You need a cross-functional team. And in this case, it's even larger than the one of DevOps, because you need to have people involved from all the different functions that you have in your company, because you cannot work with the IT people only. You need also people that take care about customer relationship, being in sales or marketing, or being in the invoicing and financial purchase or payment, or being the one that provide customer support, because the entire flow of a service that is delivered to the end user, to the customer, start with all the kind of contact you have with the customer. And so you need to have sponsors in each of the function to be sure they are willing to cooperate on the mapping. And the mapping is the first activity, and it can be quite a long exercise. And again, it can be done incrementally. So you need to map your current state. And this is actually creating a visual representation. So you are not just talking about that, but you are really creating a visual representation. There are tools to do that. We will mention some later, where you define which are the different phases. And for each of the phases, you can understand the level of the composition you want to have, depending on how big these phases are. And for each of these phases, you need to identify which is the not only the relationship, the flowchart we were talking about before, but the measurement of each of that. You see in the sample that is in this slide, you have the lead time, the cycle time, the defect rate, and then you have the wait time between phases. And so you can understand how long it takes for an activity to flow through all the stages. So let's imagine you have a requirement, then the requirement becomes a user story, it sits on the backlog, then it goes into your sprint. Let's imagine you're working on Scrum. how long does it take usually for something from when it's expressed from the customer, from the stakeholder, to actually be in your sprint backlog? How long stories stays in the product backlog before going into the sprint backlog? And then you can find wait time before the peer review is doing. So you have created your pull request. For example, we're working on your repo. How long does it take before your colleague will take a look at that and will provide an answer? And then how long it will take to actually create the answer? And so far for each of the different stages. And you first need to design the flow. So to do that, you need to interview the people, because something is your process on paper that already existed before you started this, but something is what is actually happening on the field. And you need to track what is happening on the field, not what is the theory. And then you need to put in place mechanism to track some actual value, because as I said already before, this is not much about your perception about what is working or what not. It's something that is important to collect. There are different templates that can be used for VSM, and one of the templates allow you to collect what is the perception of problems that your colleagues or your customer has. But then everything has to be based on numbers. So you need to put in place something that allow you to get the number, and we will come also to that after. Once you have mapped the current states, you can start identifying the waste and bottleneck. So you analyze that, you identify which are the more evident, the biggest or the simplest waste, and you start to design your future state. So you change your flow, you define also your target, and you define which are the action to achieve that the target, and then you can try to implement that. Usually you do with a pilot with a certain period of time, you measure that, you need to go to a training to the people. And one of the things that is most difficult in all this is collecting this data and then to monitor to continuously improve. Why? Because you need to have the right tool and the right process, but also the right understanding by the people that are working on the flow in order to collect the data. I make a simple and stupid example now. If you need to measure the queue time for an activity to go from being on the backlog to be processed and then to be released, you can measure it through your Kanban board or Scrum board, Jira or whatever you are using. But then if your team are not updating the status of the item, your data are not really representing what is happening. So you need to understand how data are collected so that the data are valuable. Let's try to imagine an example of implementing all this. So let's consider there's a software development team that builds and deploy a web application. We need to map this value stream. So when we map the value stream, we create, as I said before, an actual diagram. The diagram has a set of key elements, process boxes. And there are also standard of the symbols to be used for VSM. Process boxes that represent the different stages, the arrows that indicate the flow. And you usually have different kind of arrows because you need to define which are material flow or information flow. So which are flow that are just related to exchange of information. For example, because you need to notify some people of things, and the flow that is the actual flow of your artifacts that are produced and move forward. These two flows can be two different and parallel flows that happen at the same time. Then you need to identify which are the different actors involved in each of the flow. In this diagram that we have here, for example, we have something related to the release. So we are going to release something. Our software development team that need to build and deploy the application before deploying it, it needs to go through QA and different part of testing. In this flow, we can see that there is a very long lead time in the regression testing. 30 days of lead time in the regression testing. 14 days in the QA feature testing. And there's also 35% of complete and accurate, what it means, things that are really passing what is going there. That is very low. If we look after, we can see that deployed to production has a lead time of 3 days and has an 80% of complete and accurate. And then we have other element, I mean, they're going to go in each of the box there. So looking at this diagram, we can, because we have collected all this data and we see also which are all the different data flow, information flow that goes through the different channel and how things can go back in time. We can see that definitely a point to be improved in this schema, if you look at that, is the pull request and code review phase. Or better, what is happening before in terms of output that is in the code solution. Why? Because the percentage of complete and accurate drop from the 85% of the code solution to 35% of that phase. So that is a phase where things are looping continuously between those two stages. And then we could invest on the regression testing, where we have a high percentage of failure with also very long lead time. So we could invest in some automation there in order to reduce the time. But then we can also invest in an automation that anticipates the test during the coding phase, so that the percentage of failure during that phase will go down. If we look at this schema, we could say, okay, that there's no need in this moment here to invest in the deployment or release phase, because lead time is quite short compared to the rest in percentage, and the percentage of complete and accurate is very high. So we can have a clear view on where we can do our intervention. If we look at this other schema, we can see that there is a lot of inefficiency in the initial phase of the project on passing the information. The red numbers under the arrows are the queue time. So the time that is passing before something that is completed in the precedent stage is starting in the next one. If we start from the request, so it comes a request from the end user. It's half an hour of work, and it's immediately done. But then, to approve the request is something that takes 10 minutes, but from the moment it is inserted to the moment that is done, it takes an average of 8 hours. It takes 8 hours to do that. I mean, actually, it will take 10 minutes. 0.5, or I mean 0.1. I don't. Here is a number written in a strange way to be hours, but a fraction of an hour. But with a complete lead time, cycle time of the phase of 8 hours. But more than that, before the request, once the request is completed, is executed, before it is even inserted in the queue of approval, we have 320 hours average waiting there. 80 hours between when it's approved to when it comes to the requirement, technical requirement definition phase. This is taking a total time of 160 hours, where 60 hours are the ones that are actually process hour, and the other 100 hours are just waiting there into that phase. And then we can see the boxes between review and design or test and code, where we have a certain percentage of things that come back. And we have reported here, so this is a different way to represent compared to the diagram we had before, that when code comes to testing, 65% of the time it is defective, so you need to go back. And this happens 3 times. Often, in this case, I mean, probably is taken from a company that does not have a very good unit testing capabilities. The code, the same feature, it goes back 3 times between code and testing before it's able to proceed. We were talking about lead time, process time, so try to give a short definition. A lead time is the total time it takes for a product or service from the beginning to the end of the process. And include processing time, so this is the actual time you spend on working on something. And then you have the waiting time, that is the time you wait after the end of a phase to the start of the other time. And the queue time. The queue time is what is waiting inside the phase. So you are already in the phase where you have to go, but you cannot start working on that because you're working on something else. The queue time can be highly impacted by the work in progress limit. If I have, and this is something that you can then adjust, adjusting your flow. So if you know that you have a set of steps, and for example, you are doing some development, and then you have a QA phase that has a different team that has his own tool, his own process, and you know that your QA team is able to test a maximum amount of 4 features at the same time, for example. You should plan your previous step to match that work in progress limit. If your QA team can process 4 features in parallel test, it does not gain anything to your lead time, the fact that you increase your development team and you are able to develop 15 features at the same time, because in any case, they will be queued after. So you need to identify which are the bottlenecks and try to adapt your flow. And sometimes the optimization of a value stream is to reduce the working process in steps that are capable of doing more, but this will just cause a queue in the next phase. By analyzing your current state map, that is what you design, you can then try to identify your issues and try to define your new model, your changes. You have to focus on things as long lead time, so wait time between phases, rework, as we were saying before, unnecessary task, things that can be automated or can become implicit. Very often you have process where you have some official sign-off that need to be done before you start working. So you have your requirements and then you have everything ready, but before putting things in your backlog, you need your stakeholder to sign off your requirement. And then only after that phase, you put them into your backlog. And then your team can start working into that. You can try to optimize that in different way. You can have something that is more implicit. So you can define, for example, a process where things go through your stakeholder for them to sign off. But in the meantime, you start putting them in the backlog without waiting for them to complete the sign off, and setting up a rule that everything is accepted and so inserted in this backlog unless they explicitly deny something. So instead of having a flow where you collect 10 requirements, then you pass 10 requirements to your stakeholder, and then you wait, because you need to wait for them to come back with the sign off where they will tell you, I want to do this 9 and not this one, for example. And then at that point, you analyze and put your 9 in your backlog. You can have a process where your 10 requirements come. In parallel, they go to your stakeholder for the sign-off, but they also go to your PO for having been put in the backlog. Your PO starts putting things in the backlog. And in parallel, the stakeholder check, and then the stakeholder will just communicate, I don't want this one. And the worst case is that this was already inserted in the backlog and need to be removed. But the other 9, in the meantime, have already been done. You don't have to wait and waste your lead time, complete lead time. The same thing happened on testing. If you can parallelize the testing of the feature instead of sending all of them at the end, it can create a loop of feedback that is more quick and more efficient. And here comes also a lot of things that came from the DevOps methodology. Automate repetitive tasks, implement continuous integration and delivery. So lots of the wasted time that you have are things that can be improved by implementing automation flow. But then you can work also on the batch size, so having smaller batch of activity that flow through the process, so that a block is not blocking a large list all at the same time. And you can sometimes have intervention that are not related to the flow or to the roles or to the duties, but sometimes to the tool. Sometimes your problem is just that you have different tools used by different teams that are not synchronized or not coordinated between them, so you have waste time on looking at things. I can give a very simple example of something that we have done. So we are providing services to different customers, and depending on the customer, sometimes the customer have the need to use their own board to track the activities, because they have their own visibility internally, they have their own standard, and we cannot force them to use our own board. So we have our board where we have the activity for a certain number of customer and project, but then other customer, their activity are in external board. This was causing a very extensive waste for us, because every time you have to check for the activity to be done, you have to remember that you have to check in one place, but then you have to check also in another tool and then in another one, and you have to remember to do that, to check your permission, we're not able to visualize the things together. So we made a small investment in terms of our time on finding a tool and implementing the tool that was automatically importing things into our board. I mean, it was not something that was re-architecting the world. We were not forcing our customer to do things differently. We have not changed our process, but we eliminated some of the waste of the time and also some of the rework and the mistake by just adding a tool that was helping some exception to be inside the standard flow. And then it comes about tools, and I promise I'm close to the end, so not boring you too much with that. To some of the tools that are needed to implement. I was mentioning before a tool that was a tool to make a process work better, but there are tools to apply value stream management. First tool that you can think about are general purpose diagramming tools. As I said before, something that you need when you talk about value stream management is you need to visualize and design your value stream. You need to have your chart where you have all the phases and where you put all the different measures. I mean, very often when you start, especially if you work with external consultants that help you on working into that, and sometimes it can be useful because they know the methodology and they come into your context with a fresh pair of eyes, fresh mind, and they see things that sometimes you don't see. They can pose the right question. But often if you work with external consultants, there are some workshops that are done where the diagramming tools can be really paper and post-it and things put on a wall, but at a certain point you need to have it on a document that you can share with the larger team, where things can be visualized and can be tracked. Also because, as I said before, you need to measure your current flow, you need to identify where you want to make intervention, and then you need to make the changes and then measure your changes. And so you need to track this and to visualize clearly where things are. Here you can have very standard tools for diagramming. I mean, you don't need something specific. You just could use Draw.io or Miro or Lucid.art and so far. You need to define a special version of a flowchart at the end. And then you need tool to get the measurement that you have. So you can have different tools. There are some tools that are a bit more specialized. Plutora, PlanView with ServiceNow value stream management, GitLab as a value stream analytics, Onyx is another tool. These are all tools that collect information from your Kanban or Scrum board, where you insert your work item and measure the different changes of status of your work item. You can track activity from activity on the repository of code. They can track activity from a CI/CD pipeline or support tickets that come from the end user. Some of these tools are tools that provide other features, but they can have value stream analytics or dashboard related to value stream as GitLab or ServiceNow, but they need to grab the data. So GitLab value stream analytics is something that is great, and GitLab is a great tool. So say hello to our GitLab friends, but GitLab value stream analytics is a great tool if you are working with GitLab at a full chain of services. So if you are using GitLab issue board, and then you are using GitLab repo, and you are using GitLab pipelines, then the GitLab value stream analytics, if you have a GitLab Ultimate Edition, is very useful. But if you track your stories in Jira, and then you're using ServiceNow instead to track your incident for the customer request, and you have your repo in GitLab, but then you are using Jenkins as a pipeline. Again, for our friends of Jenkins, it was a pleasure to work with Jenkins in the past. I hope will not do it in the future. The GitLab value stream analytics will be quite poor because it will miss a lot of the information that are from the outside. Plutora or PlanView, they have some tool for integration to get data from the external. The Plutora in particular is quite specialized into that. And what you need is to collect all the different sources of data. But because of this, you need to, before starting thinking of a tool, consider what are the needs, what you are using already now. In some cases, you don't necessarily need a specialized tool for VSM. I mean, can be useful, can be a way of doing it. But in this slide, for example, you see some graph that you can recognize the style. It's the Grafana dashboard. What you need is to identify where you have the information. And in many companies, your information will be spread across different tool sets. I was mentioning already before, Jira and ServiceNow and GitLab and GitHub, and then you have Circle.io or Spinnaker or other CI/CD pipeline, and then you have maybe Argo CD or Flux for the GitOps part. So you have many elements where you have data. So what you would need maybe is something to just collect those data. So something you can do, I mean, on our side, for example, we are building this out of our, I mean, we built a data API solution. It's called mzinga.io, and we build it as something that is just a collector. So it does not have any specific business logic. It just collect data that you just normalize in documents, JSON documents, and you collect data from the different sources. And then once you have all the data collected in a central location, you can use also a standard tool as a Grafana just to create your dashboard and try to visualize it. And you need to make consideration about the cost. I mean, how much budget you can have available to work under your value stream management. And also, which are the tools that are already existing in the company? What is the effort of making them change in the tool? As I was saying before, if you have or you are happy to use GitLab Ultimate and you can use GitLab issue board for everything, then you have everything inside GitLab. The value stream analytics of GitLab is great and is everything there. But if you are using different tools for different purposes, you need to collect the data together. To do value stream management, you need to have the information about how requests are collected from the customer, where they are, how long they stay in their first repository, when they are analyzed, how you transform them into requirements, where those requirements are available, all the flow of the requirements to become analysis or task or user story, how the tasks are proceeding. Then you need to collect information about your coding activity, how many releases you're doing, how many builds you're doing, tests, percentage of failure of your test, duration of your test, duration of your execution of your pipeline, your deployment, the tests you're doing in production, the incidents that are reported by the end user or by the monitoring tool. You need to collect all this data together. Obviously, it seems a very large amount of data you need to collect with a very large effort to get all this. You can start small, as I said before. So to try to go to the conclusion, the value stream management is in the digital area an evolution of Lean to be, or something that we extracted from Lean to be specific, adapted for the digital area. In the digital area, we are not missing data. Sometimes we are missing the ability to collect and analyze them, but we are very rich in terms of data. And we can integrate the Lean principle into our system management, into the organization, and try to bridge the gap between Lean, Agile, DevOps, and try to put this all together to identify in the entire workflow that we have from the idea to the release of the idea, which are the elements where we are not efficient and we can add efficiency into that. And because it's complex, because you have to collect a lot of data, you need to analyze a lot of data, as is on the last sentence, start small and scale gradually. In the slide, we put some links. I tried to do it a bit different than I did in the past. So as you see here, they are not actual link, but I did it because also the video will remain. It's easier than to see the slides on the video. And for the member of the meetup group, you can just ask and they can forward the slide to you. Links are then something that if you cannot click on them, you can not really use. So this is a bit more easy to use from the video. You can see is the title of the article and the name of the site where the article is expressed. So if you write exactly the sentence in Google, I tested each of them. If you write exactly the sentence in Google or Bing or any other search engine you want, the first result is the page that is reported there. These are some of the documents or articles that I found more interesting to try to get a bit more details about what value stream management is, how to implement that. In particular, the one in the how to create a value stream map step by step with example is very interesting because it has some actual example of forms of question that you can pose to your stakeholder to collect the information, and are all quite short paper that you can try to use to get more details. I hope this has been clear and interesting enough for all of you. So I'm available for any question you may have. I know it's a Friday evening. It's Black Friday too. So it's people maybe have to go to buy things. You will be able to view the video again in our channels. So if you miss it, you can view it on demand and then leave any comments or questions you may have. So thank for you all to having been here with us. And if you have any question, feel free to write to us in our channel.